Section 4 of National Geographic Magazine, Volume 1, Number 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Marianne. The Rivers and Valleys of Pennsylvania, Part 3b, by William Morris Davis. 18. Examples of adjustment. Another case is roughly figured in the next three diagrams, figures 16, 17, 18. The two adjacent synclinal streams, EA and HB, join a transverse master stream, but the synclines are of different forms. The surface axis of EA stands at some altitude above the baseline until it nearly reaches the place of the transverse stream, while the axis of the other, HB, descends near base level at a considerable distance from the transverse stream. As lateral valleys, E and D, are opened on the anticline between the synclines by a process similar to that already described, the divide separating them will shift towards the stream of fainter slope, that is, toward the syncline EA, whose axis holds its hard beds above base level. And in time the upper part of the main stream will be withdrawn from this syncline to follow an easier course by crossing to the other, as in Figure 17. The elevation of the syncline axes, AES, take the shape of a long flat arch descending at the further end into the synclinal lake basin, S, whose outlet is along the arching axis, SA. Then the mature arrangement of stream courses will lead to the lake outlet away from the axis by some gap in the nearer ascending part of the arch, where the controlling hard bed falls near to base level, as at F, Figure 18, and will take it by some subsequent course, FD, across the lowland that is opened on the soft beds between the synclines, and carry it into the lower syncline, HB, at D, where the hard beds descend below base level. The variety of adjustments following the general principle here indicated is infinite. Changes of greater or less value are thus introduced in the initial drainage areas until, after attaining an attitude of equilibrium, further change is arrested, or, if occurring, is relatively insignificant. It should be noticed that the new stream courses thus chosen are not named by any of the terms now current to express the relation of stream and land history. They are neither consequent, antecedent, nor superimposed. The stream is truly still an original stream, although no longer young, but its channel is not in all parts strictly consequent on the initial constructional form of the land that it drains. Streams thus rearranged may therefore be named original streams of mature adjustment. It should be clearly recognized that the process of adjustment is a very slow one, unless measured in the extremely long units of a river's life. It progresses no faster than the weathering away of the slopes of a divide, and here as a rule weathering is deliberate to say the least, unless accelerated by a fortunate combination of favoring conditions. Among these conditions, great altitude of the mass exposed to erosion stands first, and deep channeling of streams below the surface, that is, the adolescent stage of drainage development, stands second. The opportunity for the lateral migration of a divide will depend on the inequality of the slopes on its two sides, and here the most important factors are length of the two opposite stream courses from the water parting to the common base level of the two, and inequality of structure by which one stream may have an easy course and the other a hard one. It is manifest that all these conditions for active shifting of divides are best united in young and high mountain ranges, and hence it is that river adjustments have been found and studied more in the Alps than elsewhere. 19. Revival of rivers by elevation and drowning by depression. I make no contention that any river in the world ever passed through a simple uninterrupted cycle of the orderly kind here described. But by examining many rivers, some young and some old, I do not doubt that this portrayal of the ideal would be found to be fairly correct if opportunity were offered for its development. The intention of the sketch is simply to prepare the way for the better understanding of our actual rivers of more complicated history. At the close or any time during the passage of an initial cycle such as the one just considered, the drainage area of a river system may be bodily elevated. The river is then turned back to a new youth and enters a new cycle of development. This is an extremely common occurrence with rivers, whose life is so long that they commonly outlive the duration of a quiescent stage in the history of the land. Such rivers may be called revived. Examples may be given in which streams are now in their second or third period of revival, the elevations that separate their cycles following so soon that but little work is accomplished in the quiescent intervals. The antithesis of this is the effect of depression, by which the lower course may be drowned, flooded, or fjorded. This change is, if slow, favorable to the development of floodplains in the lower course, but it is not essential to their production. If the change is more rapid, open estuaries are formed, to be transformed into delta lowlands later on. 20. Opportunity for new adjustments with revival. One of the most common effects of the revival of a river by general elevation is a new adjustment of its course to a greater or less extent as a result of the new elevation of base level to the hard and soft beds on which the streams had adjusted themselves on the previous cycle. Synclinal mountains are most easily explained as results of drainage changes of this kind. Science, December 21st, 1888. Streams thus rearranged may be said to be adjusted through elevation or revival. It is to be hoped that, as our study advances, single names of brief and appropriate form may replace these paraphrases, but at the present it seems advisable to keep the desired idea before the mind by a descriptive phrase even at the sacrifice of brevity. A significant example may be described. Let it be supposed that an originally consequent river system has lived into advanced maturity on a surface whose construction is like that of Pennsylvania, composed of closely adjacent anticlinal and synclinal folds with rising and falling axes, and that a series of particularly resistant beds composes the upper members of the folded mass. The master stream, A, figure 19, at maturity still resides where the original folds were lowest, but the side streams have departed more or less from the axes of the synclinals that they first followed, in accordance with the principles of adjustment presented above. The relief of the surface is moderate except around the synclinal troughs, where the rising margins of the hard beds still appear as ridges of more or less prominence. The minute hachures in figure 19 are drawn on the outcrop side of these ridges. Now suppose a general elevation of the region, lifting the synclinal troughs of the hard beds up to base level or even somewhat above it. The deepening of the revived master stream will be greatly retarded by reason of its having to cross so many outcrops of the hard beds, and thus excellent opportunity will be given for readjustment by the growth of some diverting stream, B, whose beginning on adjacent softer rocks was already made in the previous cycle. This will capture the main river at some upstream point and draw it nearly all away from its hard path across the synclinal troughs to an easier path across the lowlands that had been opened on the underlying soft beds, leaving only a small beheaded remnant in the lower course. The final rearrangement may be indicated in figure 20. It should be noted that every capture of branches of the initial main stream made by the diverting stream adds to its ability for further encroachments, for with increase of volume the channel is deepened and a flatter slope is assumed, and the whole process of pushing away the divides is thereby accelerated. In a general way it may be said that the larger the stream and the less its elevation above base level, the less likely it is to be diverted, for with large volume and small elevation it will early cut down its channel so close to base level that no other stream can offer it a better course to the sea. It may also be said that, as a rule, of two equal streams, the headwaters of the one having a longer or harder course will be diverted by a branch of the stream of the shorter or easier course. Every case must therefore be examined for itself before the kind of rearrangement that may be expected, or that may have already taken place, can be discovered. 21. Antecedent and superimposed rivers. It not infrequently happens that the surface, on which a drainage system is more or less fully developed, suffers deformation by tilting, folding, or faulting. Then, in accordance with the rate of disturbance, and dependent on the size and slope of the streams and the resistance of the rocks, the streams will be more or less rearranged, some of the larger ones persisting in their courses and cutting their channels down almost as fast as the mass below them is raised and offered to their action. It is manifest that streams of large volume and considerable slope are the ones most likely to persevere in this way, while small streams and large ones of moderate slope may be turned from their former courses to new courses consequent on the constructional form of the land. Hence, after disturbance, we may expect to find the smaller streams of the former cycle pretty completely destroyed, while some of the larger ones may still persist. These would then be called antecedent streams in accordance with the nomenclature introduced by Powell. A further acquaintance with the development of our rivers will probably give us examples of river systems of all degrees of extinction or persistence at times of disturbance. Since Powell introduced the idea of antecedent valleys, and Tietz, Medlicott, and others show the validity of the explanation in other regions than the one for which it was first proposed, it has found much acceptance. Lull's objection of it does not seem to me to be nearly so well founded as his suggestion of an additional method of river development by means of backward headwater erosion and subsequent capture of other streams, as already described. And yet I cannot help thinking that the explanation of transverse valleys as antecedent courses savors of the Gordian method of explaining a difficult matter. The case of the Green River, to which Powell first gave this explanation, seems well supported. The examples given by Medlicott in the Himalayas are as good, but still it does not seem advisable to explain all transverse streams in this way, merely because they are transverse. Perhaps one reason why the explanation has become so popular is that it furnishes an escape from the old catastrophic idea that fractures control the location of valleys, and is at the same time fully accordant with the ideas of the uniformitarian school that have become current in this half of our century. But when it is remembered that most of the streams of a region are extinguished at the time of mountain growth, that only a few of the larger ones can survive, and that there are other ways in which transverse streams may originate, it is evident that the possibility of any given transverse stream being antecedent must be regarded only as a suggestion until some independent evidence is introduced in its favor. This may be difficult to find, but it certainly must be searched for. If not then forthcoming, the best conclusion may be to leave the case open until the evidence appears. Certainly, if we find a river course that is accordant in its location with the complicated results of other methods of origin, then the burden of proof may be said to lie with those who would maintain that an antecedent origin would locate the river in so specialized a manner. Even if a river persist for a time in an antecedent course, this may not prevent its being afterwards affected by the various adjustments and revivals that have been explained above. Rivers so distinctly antecedent as the Green and the Sutlej may hereafter be more or less affected by processes of adjustment which they are not yet old enough to experience. Hence in mountains as old as the Appalachians, the course of the present rivers need not coincide with the location of the pre-Permian rivers, even if the latter persisted in their courses through the growth of the Permian folding. Subsequent elevations and adjustments to hard beds, at first buried and unseen, may have greatly displaced them, in accordance with Lull's principle. When the deeper channeling of a stream discovers an unconformable subjacent terrane, the streams persist at least for a time in the courses that were determined in the overlaying mass. They are then called superimposed (Powell), inherited (Shaler), or epigenetic (Richthofen). Such streams are particularly liable to readjustment by transfer of channels from courses that lead them over hard beds to others on which the hard beds are avoided. for the first choice of channels, when the unconformable cover was still present, was made without any knowledge of the buried rock structure or of the difficulties in which the streams would be involved when they encountered it. The examples of falls produced when streams terrace their flood plains and run on buried spurs has already been referred to as superimposed, and the rivers of Minnesota, now disclosing half buried ledges here and there, may be instanced as illustrating the transition stage between simple consequent courses, determined by the form of the drift sheet on which their flow began, and the fully inconsequent courses that will be developed there in the future. 22. Simple, compound, composite, and complex rivers. We have thus far considered an ideal river. It now seems advisable to introduce a few terms with which to indicate concisely certain well-marked peculiarities in the history of actual rivers. An original river has already been defined as one which first takes possession of a land area, or which replaces a completely extinguished river on a surface of rapid deformation. A river may be simple if its drainage area is practically one kind of structure and of one age, like the rivers of southern New Jersey. Such rivers are generally small. It may be composite when drainage areas of different structure are included in the basin of a single stream. This is the usual case. A compounded river is one which is of different ages in its different parts, as certain rivers of North Carolina, which have old headwaters rising in the mountains and young lower courses traversing the coastal plain. A river is complex when it has entered a second or later cycle of development. The headwaters of a compound river are therefore complex, while the lower course may be simple in its first cycle. The degree of complexity measures the number of cycles that the river has entered. When the study of rivers is thus attempted, its necessary complications may at first seem so great as to render it of no value. But in answer to this, I believe that it may be fairly urged that although complicated, the results are true to nature, and if so, we can have no ground of complaint against them. Moreover, while it is desirable to reduce the study of the development of rivers to its simplest form, in order to make it available for instruction and investigation, it must be remembered that this cannot be done by neglecting to investigate the whole truth in the hope of avoiding too great complexity, but that simplicity can be reached safely only through fullness of knowledge, if at all. It is with these points in mind that I have attempted to decipher the history of the rivers of Pennsylvania. We find in the Susquehanna, which drains a great area in the central part of the state, an example of a river which is at once composite, compound, and highly complex. It drains districts of diverse structure, it traverses districts of different ages, and it is at present in its fourth or fifth degree of complexity, its fourth or fifth cycle of development at least. In unraveling its history, and searching out the earlier courses of streams which may have long since been abandoned in the process of mature adjustment, it will be seen that the size of the present streams is not always a measure of their previous importance, and to this we may ascribe the difficulty that attends the attempt to decipher a river's history from general maps of its stream lines. Nothing but a detailed examination of geological structure and history suffices to detect facts and conditions that are essential to the understanding of the result. If the postulates that I shall use seem unsound and arguments seem overdrawn, error may at least be avoided by not holding fast to the conclusions that are presented, for they are presented only tentatively. I do not feel by any means absolutely persuaded of the correctness of the results, but at the same time deem them worth giving out for discussion. The whole investigation was undertaken as an experiment to see where it might lead, and with the hope that it might lead at least to a serious study of our river problems. End of section 4.